Welcome back everyone for another SVSU Math and Physics Resource Center tutoring video. My name is Brendon. I'm going to be your math tutor, and this is going to be the final video for the root test. So root test part 3. Hope you guys enjoy the video. Alright, so let's get into the root test part 3. So before we do this example that I have right now, let's go ahead and recap what the root test does. So we start out with the series as n ranges from k to infinity of a of n, which is a function of n. So what we're going to do for the root test is we're going to take the limit as n approaches infinity of the nth root of the absolute value of a of n. And if we can get that to equal some value L, we can use these three criteria to tell us whether the series converges, diverges, or if the root test is inconclusive. So for example, if L is greater than 1, the series is going to diverge. If L is less than 1, the series is going to converge absolutely. And if L is equal to 1, that tells us that the root test is inconclusive and we have to try another series test. Okay, so let's go ahead and get right into this example. So the first thing I'm going to do is I'm going to point out my a of n term. Okay, and then it looks like we have everything we need to go ahead and plug it into the limit. So we have the limit as n approaches infinity of the, I'm just going to go right to the fractional exponent. So 1 over n cubed to the 1 over n. Okay, now for this next step I'm going to rewrite the inside to maybe make it a little easier on us. So we have the limit as n approaches infinity of the absolute value of n to the negative 3 to the 1 over n. Okay, so now we have exponent being raised to another exponent, so we're going to multiply those. So we're going to end up with the limit as n approaches infinity of the absolute value of n to the negative 3 over n. Okay, so now that we have that, if we try to plug in our limit, let's see what we get. It looks like when we plug in our infinity to the exponent, we're going to get negative 3 over infinity, which is going to go to 0. And then we have an n down here, so it's going to be infinity to the 0, which is an indeterminate form. Okay, so now what we have to try to do is we have to try to algebraically manipulate this so we can get it into either the indeterminate form of 0 over 0 or infinity over infinity. Okay, so first thing I'm going to do is I'm going to take e to the ln of the limit as n approaches infinity of n to the negative 3 over n. Okay, we can do that because the e to the ln, those are going to cancel each other out because they're inverse functions. Okay, and so now what we want to do is we can use our limit rules and we can take our ln and we can put it inside of the limit. So we're going to have e to the limit as n approaches infinity of the ln of n to the negative 3 over n. Okay, and so now using our natural log rules, we can take our exponent and we can move it out front. Okay, so what that's going to look like is going to be e to the limit as n approaches infinity of negative 3 over n ln of n. Okay, and so now that we have that, we're really close. We just need to put this n on the denominator. So this is going to be e to the limit as n approaches infinity of the negative 3 times the ln of n divided by n. And if we take the limit now, we're going to get infinity over infinity, which then this tells us that we can use L'Hospital's rule. So I'm going to put a little equal sign, and put a little h, denoting that we're using L'Hospital's rule. And so then we're going to end up getting e to the limit as n approaches infinity. So L'Hospital's rule says we take the derivative of the top and then we take the derivative of the bottom. So the derivative of the top is going to be negative 3 over n divided by, so then derivative of the bottom is going to be 1. So now when we take this limit, we're going to end up with negative 3 over infinity, so then this is going to approach 0, and then divided by 1 is still going to be 0, so we're going to end up with e to the 0, which is equal to 1. So let's go back to check our criteria. We definitely don't have L is greater than 1. We don't have L is less than 1. So we have this third case here. So L is equal to 1. So then that tells us that the root test is inconclusive. So we weren't able to determine if the series converged or diverged using the root test for this example. However, so that just tells us we need to use a different a series testing method. And then for this particular series, A of n is equal to 1 over n cubed. This is a p series with p being equal to 3, which is greater than 1, which tells us that it converges. Okay, so that's why knowing all of your different series tests is really important, because doing the root test for this example ended up being a pretty long step-by-step process to come down to the answer of the root test being inconclusive. But if you're able to look at that right away and say, oh, that's a p series, we're able to just tell that p is greater than 3, so it tells us that the series converges. All right, hope you guys enjoyed the video. Thank you.